my screen. So once again, thank you for being here. Thank you for taking the time. Let's start with the introduction to machine learning. A bit about myself. My name is Jose Pauyac Estrada. I am a petroleum engineer currently doing a PhD in CO2 storage in the US. Mutia, Uganda. Even though I am a petroleum engineer, I have used machine learning for real problems. During my PhD, I built a neural network model to see how the CO2 behaves underground. A journey that includes Uganda. I have studied in Russia, Austria, and now in the US, and I have done internships in Germany, Uganda, Saudi. So I have been in Uganda before. In 2022, I went for an internship for 2 months internship, and I helped with my colleague Paul that we introduced programming lessons to students at Makerere University. I'm still learning and always adapting. Different countries, languages, cultures, and classrooms taught me how uncomfortable learning can feel and why it is worth it. So I would like to give a moment to give to thanks Uganda. I would like uh, to thank my supervisors, Dr. Gabriel Casosi and Dr. Simon Ichigo, who is here in the meeting. So I am very grateful. And as I said, in 2022, I lived in Uganda. I worked, studied there in your lecture halls, your field sites, and your streets. So tonight is the time to give a little back of what I received from you guys. So let's start. Many of you probably have seen like 20 years ago, 15 years ago, some movies when robots move like humans. For example, in 2004, the movie I, Robot with Will Smith. And then in 2011, there was a second movie called I'm sorry, I'm going to ask please to mute the microphone. Or like in real still that we saw in 2011 that the robots were fighting. Well, guess what? Nowadays, these are not science fiction anymore. These are real. In China, for example, there was a race of robots in which they beat the human record. And also, like in the Real Steel movie, we have seen robots fighting with each other, exactly like humans do. So have you imagined any world in which robots interact with each other like humans do? Like, for example, we go to Facebook, Instagram, LinkedIn, we post, comment, make jokes. Well, this is already true. We see that there is a social network purely for AI in which humans cannot interact. Humans are only allowed to see what the robots are doing. So the science fiction is becoming real. The first time I saw like a robot delivering, like, let's say, parcel or food, it was back in Russia in 2022. And it surprised me because the robot, once it was reaching a traffic light, I thought it was not going to stop in a red light, but I came to know, and it was a big surprise for me that when the red light was red, the robot stops like any other human. And when it was green, it went. So now robots are moving like us. We have cars that are driving themselves, and we have AI that creates. Like, for example, you have Gemini, ChatGPT, Claude, and all of the AI agents which can create images, videos, and so on. What is the engine behind all of this? Well, the answer is machine learning. exactly what you will start learning tonight. So let me ask the audience, have you ever used machine learning today? Please feel free to unmute yourself or drop your answer in the chat. Well, probably many of you have not used machine or think that you have not used machine learning at this point, but let me tell you that you are not more wrong. You have been using machine learning, for example, when you take your phone and you want to unlock it with your face, or also when you go to Google or to Alexa from Amazon and you want to ask the weather, or for example, when you are scrolling on social media and you suddenly saw a For You video that you actually like, or for example, when you are in a foreign country, like for me, I was using a Google Translator to use my voice to translate from English to Luganda. Also, when you are in the traffic and you are using Google Maps and you get lost or you miss a turn, then Google Maps reroutes your way. Or has it happened to any of you that you have been recommended a movie on Netflix based on your taste? If you have ever done any of these, congratulations, you have been already using machine learning. So there is no mystery about this. So what exactly is machine learning? Like, based on its name, we can say that it's a machine which is learning. And what does this mean? There is the traditional programming in which you give the machine certain instructions and the machine will understand. Like, for example, if you say to the machine, if the email says free money, then mark as spam. The real problem with this is there are millions of rules in the world and you cannot type all of them. Therefore, machine learning is a better way to do this. You give, let's say, 10,000 emails that are already labeled spam and not spam. So when you give, let's say, 1,000 more emails, the machine will find the patterns behind this and it will handle emails it has never seen before. So in one line, machine learning learns from example instead of being told every rule. As said, machine learning is already in everyone's pocket. In the phone keyboard, when you are typing, the machine already knows what you want to say. When you use your face to unlock your phone, when you are on social media, when you are on the street driving using Google Maps, or when you receive fraud alerts to your mobile, or when you are just shopping. There are three main flavors for machine learning. First one is supervised, which learns from labeled examples, unsupervised, which the machine finds hidden groups from unlabeled data, and reinforcement learning, which is learns by trial, reward, and error. What are these? The first one, supervised learning, is when you give the machine examples that are already labeled with the right answer. It learns the pattern that links each input to its label. In case of unsupervised learning, you just feed all the data with no any label. The machine, it will find hidden instruction on its own, and it will
Yeah.
group similar things together without being told the answer.
Sí, pues, amiga, yo. ¿Cómo se llama?
Reinforcement learning, it's when the machine learns by doing. Good move, it gets reward or penalized. But what exactly means that a computer gets rewards or being penalized? For example, if the computer makes good move, then it earns 10 points. Otherwise, if the move is bad, then it loses 10 points. This is reinforcement learning. And how actually the machine learns? Well, the same way we did. It tries, gets feedbacks, adjusts, repeats, and improves. You remember when we were learning how to walk? We were walking, and then out of a sudden we hit ourselves to the wall or to the table, and then we get the feedback, which is it hurts, and then we cry. So, and if we do this thousands of times, then our brain, we will know that there is something that we shouldn't hit, otherwise we will be hurt. So the machine learns the same way. It collects the data, it trains a model, it makes a guess or prediction, gets a feedback, improves and repeats. So the magic here is repetition. Every loop, the model gets a little less wrong. Many of you probably are thinking that machine learning is very complicated and it's very hard to learn. So let me tell you that first, you don't need to be a math genius. All you need All you need to know is basic logic. The heavy maths, it's handled by tools that for now you don't need to worry about. Also, many of you probably heard that you need a very expensive computer, a very powerful one to run machine learning models. And let me tell you that this is also a myth. Google Colab gives you a powerful machine, which is for free and it's in your browser. All you need is a internet connection. Also, probably you heard that you must need to have experience in coding. Well, let me tell you that you can build a working model with no code at all. There are free tools online, like Teachable Machine, which do the hard part. Also, probably you may think that it's only for people abroad in Europe, US, and so on. Well, AI is not only for Silicon Valley. Uganda and Africa need local builders who understand local problems. So recently there was in May 2026, the Uganda Deep Tech Summit, in which one of the speakers said, an AI tool built for Silicon Valley will not necessarily work for a farmer in Mbale or a health worker in Karamoja. So according to the World Economic Forum, 170 million new jobs are expected globally by 2030. AI and machine learning specialists top the fastest growing roles. 86% of companies expect AI to transform their business by 2030. And 2 in 3 businesses plan to hire people with AI skills by 2030. So before we go to the next stage, I would like to show some pictures in order for you not to get bored. So these are some pictures when I was in Uganda. My friend, he's from Germany. His name is Paul. We both went to Uganda in 2022, and I learned a lot. I will show some short videos. For example, this is when we took a boda boda ride in Kampala. And also with Dr. Simon Ichigu, we went to a field trip like 6 hours away from Kampala. The region is called Kagadi. And we were doing this almost every day, which is very exciting for me. Say hi. And because not everything is work, we also found some time to have fun. Here is a video in Kagadi. No. So now it's time to write some code. As I said, in this picture, my friend and I were in Macarere University in one of the classrooms. We were taking some course, course, which is a software in the petroleum industry. And Paul and I, we wrote some code to, uh, let's say, to introduce Macarere students to the programming world. This here we did together. This is Python, and here app is VBA, Visual Basic Application, which is from Excel. So yes, you can code in Excel. So what are we going to do for the live demo? I will show you how to build your very first machine learning model, which is called linear regression. The idea behind linear regression is when you have a lot of data, the machine tries to find like a line which will fit most of the data. In this case, the line will be like a linear. For this, we will first load the data, then we will find the best fit line to the data, and we will predict a new value. We will use the exchange rate, a history exchange rate between USD and UGX. So this is how the linear regression will be. And also you will learn how to do a forecast, how to predict, let's say 12 months in the future or 6 months in the future. After this, I will show you also regression, but instead of linear, a polynomial. And as we can see here, the curve, it fits more or less better than the linear one that we had before. And also we can predict in the future. So let's start with this. So for those who are not let's say for those who have no experience in coding, I encourage you to go to this website, which is which my well, this website was developed by my cousin, and he invited me to write some tutorials. So this is very basic. I explain how to start coding with Python. But again, this is very basic. If you want a more detail, you can join the course which is provided by S-Tartex. Set this, please go to your browser and go to Google Colab. When you go to Google Colab, you will probably find something like this. And you just click here at the bottom where it says New Notebook. So just a very quick coding in Python. It would be, for example, you can define variables like this. You name a variable A, which is equal to 3, then a variable B, which is 4. And then let's say you want to sum. The way you can sum is you can define a variable C, which will be A plus B. And if you want to see the variable, you can print C, and the answer will be, well, 3 plus 4 it will be 7. It's taking one. 7, as we can see here. So let's start with the machine learning model. First of all, let's call a variable called data. For that, we will use the Yahoo Finance website, gf.download. And we will write USD UGX equal X. Start, we define from where we want the data. Let's say we want the data from last year, from June. And we want the data to be up to, let's say, one year, a bit more than 1 year. So if we run this, we will get an error. And this error is because we have not defined what YF means. The computer does not understand. So for that, we need first, in Python, there is something called libraries, and we need to import them. So we import the library from Yahoo Finance. So we import Yahoo Finance as YF. YF is just a nickname. If we don't write this, for example, if I delete this, the code will still give an error because it doesn't know what YF is. If we just write this, then we would need to write the entire name here, and it actually runs. So because writing all of this, when you write like thousands of code, is very time consuming. So we just give nicknames to the libraries. If we want to see how the data looks like, we do print data. We run and we can see the data from the Yahoo Finance website. Then we can click new code, and we will do some very basic data manipulation. So we will write data.columns equal data.columns dot get level values. As you can see here from the data, we have this header, which is close, high, low, but then the raw data gives us a second header, which is this. And for our need, we don't need this. So in order to get rid of the second header, we just simply do this. And after that, we can print the data again to see how it has been manipulated. And as you can see, we see only the first header: price, close, high, low, open, volume, without this second one. So now we add another code, and if you notice here, we have the columns price, close, high, low, open, volume in the same row, but then the column date is in a different row. In order to make all of them at the same level, we do the following. We call our variable data, and we write data.reset index. And to see how the data has been modified, we have this. So now we can see date in the same row than the other ones. It's just easier for, let's say, manipulating the data. But also now we want, because it's very hard to imagine how the data looks like if it's in a table, then we need to plot. And how to plot? In order to plot, we write plt.plot data the column date. We are plotting date with, let's say, with this one with close. So we write data date, then comma data, and then the second column that you want. In this case, close, and we close parentheses. So as you can see, again, we get an error, and this is because, same as before, the computer does not understand what PLT means. In order to plot in Python, we need a library called matplotlib. So we import that library, import matplotlib.pyplot as PLT. And now if we rerun the model, then we see the graph, how our data, the data that we have imported looks like. You can do many things with this graph. For example, let's make a title. For that, we just write plt.title and whatever you would like. Let's say USD to UGX exchange rate. And also, if you want to label the axis, this is y-axis, this is x-axis, we can do that. In the x-axis, we have date, and in the y, we have the exchange rate. And this is how our plot would look like. Now, next, we need to prepare our data for the machine learning model. And in order to do this, we do the following. We call the column data. So first, we will create a new column, which is called date ordinal. This will be our new column in the data. We call pd.to date frame. And if you notice, AI already knows what I want, so it just did it for me automatically, saving time. So now we print our data, and as we can see, again, we get an error because the computer doesn't understand what PD is. So we need to import the library pandas in order to make this code work. And as you can see, we have created a new column. The new column is date ordinal, which is here. And what does this mean? The computer, when you want to do a machine learning model, the machine will not understand this format of date. So there is like a convention internationally in which you define the time, each day, each hour, each second with numbers. That's why it's called date ordinal. And I don't remember at what time and what day exactly number one is, but this date, which is 2nd of June of 2025, this corresponds to this number. Now let's start with another line of code. And we define a new variable called x from our data, and we say data date ordinal. and a second variable y. Data close. Because for our machine learning, what we will do is we will take the date, but as I mentioned, the computer does not understand this format. So instead of this column, we will take this column. So our X will be that column. And then for the predictions for the machine learning model, we will take this column, the column close. So we can visualize X and Y. But there's narrow. Okay. So again, this is X. We took only the date ordinal and Y, which is the value. So if we want to plot, we will do the same thing we did here. We can just copy and paste. And we will do some modifications. We want to visualize X and Y. So instead of this, we just do X and Y. And the rest stays the same. And as we can see before, it's the same graph, exactly the same graph. The only difference is how the format of the data has been changed. Here we have in this format, and here we have in the ordinal format with numbers. But the graph is exactly the same. So now that we have prepared our data, we go ahead and build our first machine learning model. So we will do the linear regression model. By the way, you can call the variables whatever name you want. In this case, I will call linear dash model, and we call the function linear regression. So as you can see, we just used the function linear regression. We actually do not know what the linear regression does. We do not need to know the crazy math behind this model. We just use the tool for our purpose. And if we run the code, again, it will show an error because we have no defined linear regression. So for that, we need to import the library scikit-learn. So from scikit-learn.linear model, import linear regression. Oh, sorry. So the code has run successfully. So we have created our linear regression model, and now we want to use this model with our data X and Y that we have imported. So for that, we call our function this linear model, which is our linear regression, and we just say, okay, we want to fit our data using our function linear regression. And if we run the code, then the model has run successfully. Next, we can create a new column the same way we did before. And we can call it linear regression or linear prediction. Linear prediction will be our new column equal linear model dot predict. So what does this, what is this doing? This is taking our function, our model, linear regression, and it is going to predict based on our data only. And if we have, then you see this column, a new column has been created, linear prediction. And if we compare it to our original data, which is close, we can see that they are not far at all. But how can we visualize this? Again, in order to visualize, we need to plot. There are different ways to plot. Let's say we use the scatter plot, in which we will plot the original data. Yeah, so in this line, we plot the original data that we have imported. And in this line, we are plotting the data with our linear prediction from the linear regression model. And this is how the plot looks like, exactly the same as I showed in the presentation. And we can also have some legends. Let's do that. Let's say like for the original data, we label like the following. We call label, we call it actual rate. And then for the polynomial, for the machine learning linear regression model, we can label exactly like that. Label linear regression trend. If we run the model, you see that we do not see this legend that we have labeled for each of our plots. So in order to visualize, we just need to add one more line of code, which will allow the legend to be visible. So we add a new line called plt.legend, and now we can see the legend in this part. Now let's say, how can we predict in the future? For that, first we need to create the future dates. So how are we going to do that? First, we will define a variable called last date, in which the computer will take the last value of our data. The last value of our data is this one, is this blue dot. And from that, because we want to continue without any stop, we are taking that. So the way to do it is the following. We call the variable last date data date dot ilog and in brackets -1. This will take the last value of our date. And then we can call it next date, or we can call future date. And we will use the library pandas pd dot so let's do it. Wait, last date. So we will have the last date, and we want to add future date. So it will be plus pd time delta. We want after each day for e in range 163. What this for is doing is just looping. We say we want the next 63 future dates from starting from our list from our last date of our data. So this is the way how you write for the computer to understand. And then we can visualize. First, let's visualize our last date. And you see the last date in our data is this, June 19th, 2026. And now let's visualize future dates. So you see future dates, it will start from the next day, from 20th of June, and so on for the next 63 days, which will go up to 20th of June. Mm. 1 second, there's an error here. Mm. Here there was a mistake. Here I wrote 1, and the 1 is from one day. That's why we saw repetition of the same date, 2026, 620, 2026, 620, 63 times. So instead of 1 here, we need to write I. So that way the computer will iterate all through like 63 times. And now we see that it's changing. We have 20th of June, 21st of June, and so on. So now that we have done this, we need, again, as I said before, the computer will not understand this type of format. So we need to convert this type of format to the ordinal format, like in numbers like here. So for that, we say future ordinal equal np.array So what we are saying here is just we need all this line just to say to convert our future dates to the ordinal one. And as you can see, we get an error, and again, it's because we have not defined what NP is. NP is the library NumPy, which is for basically for math. So we first say import NumPy as NP, and now we have our new data. And once we have this, we can make the prediction. How are we going to do that? So we say we create a new variable linear future predictions, and we will call our linear model that we have created before. So linear model dot predict future ordinals, because these are the future dates that we want to make a prediction for. And as we can see, if we print this variable, we see how the UGX will change with respect to the US dollar for the next 63 days. If we want to visualize this, we can just copy the code from here and do some modifications. We copy paste So first, we have our original data, then we have the linear regression trend, and now we want our future prediction. So for that, we just do plt.plot future date, linear regression, linear future predictions. We can color green. You can color however you want. And we labeled like linear regression forecast. And as we can see now, we successfully predicted how our data will vary in the future. So congratulations, you have made your first machine learning model. And as promised, excuse me, now we will go to the second machine learning model, which is the polynomial regression. So since we have already imported our data, we are going to say poly, which stands for polynomial, and we will call a new function, polynomial feature. And here we can define the degree of our polynomial. It could be degree 2, degree 3, whichever you would like to. So if we run this again, we get an error. We need to define our function. For that, we say from sklearn.preprocessing import polynomial features. And after we define our polynomial function, then we create a new variable, xpoly, in the same way we did before. Before it was linear and now it's polynomial, so we say poly, because that is our new function, poly fit on x. And then we have that our poly model, we call again the linear regression function for the coefficients, and we made the fit in our x poly and y. So we have successfully created our polynomial regression. If you don't believe me, let's plot it. We are going to copy this part. And we say plt.scatter data date.close, which will be our actual rate. And then instead of linear, we will call the polynomial prediction. We will see how our polynomial model will be fitted in our data. So before that, we don't have yet this column. So we need to create that column. And as before, we create data, polynomial prediction, like this. So if we run the code, you have a new column with the polynomial prediction, which, as you can see, is very close to the original one. And it's not the same value as the linear prediction model we created moments ago. And if we visualize, our model will look like this. We see that the red line is better fitting our data than the previous model, than just a straight line. And now how to predict for the future, let's say 63 days again. So again, we will convert our data to ordinal format like this. This way, our future dates will be not in this format, but in number. Then after that, we define a function polyfuture predictions, and we just used our polynomial regression model on our data. And this is how the data will look like. But because it is hard to visualize, then let's plot it again. So we go here, we copy for the plotting. We have the actual rate, our original data, we have the polynomial fitting trend, and now we want to see our prediction. And as you can see, the prediction is following our polynomial regression, the one we just created. So congratulations, you have learned two models now. The first one is linear regression model, and the second one is polynomial one. And as you can see, you don't need to know the crazy math behind that. We just use the tools, we just use the function, we don't know what they do. We just use them and we create our machine learning model. Now, if you want to go deeper, then you need to understand the math behind each function. I will show you a third machine learning model, but I will not show the live demo because it's a bit more advanced. And the third model, it's called neural network. And as we can see here, our neural network is able to successfully predict our data. Before we saw in the polynomial regression, we just saw like this, a curve like this, which in our case of the linear, it was even worse, just a linear trend. But if we see with the neural network, if we see carefully, our data is decreasing and then increases, then decreases again, then increases again. So our neural network is capable of seeing all of these hidden patterns. Our neural network model is going down, then going up, going down, and going up again. So this model is very, very powerful. And the same way, we can predict for the future date. But be careful. Do not make the model fool you. Not most of the times if you have a very good model that fits your data, it does not necessarily mean that your prediction will be also good. So the real takeaway of all of these models are that if we see from all the three models that I have showed, the linear regression, it keeps climbing. The polynomial regression, it climbs even more. And with the neural network, it overshoots if we saw carefully in the prediction for the future date. And this has an explanation. The explanation is that the machine does not see any crisis coming. It cannot see a financial crisis. It cannot see whether the oil price is increasing. It cannot see an election result. It cannot know when the government or a new upcoming government is making a new policy. So all of these factors affect the economic of every single country in the world. So for that reason, even though machine learning is a powerful tool, a human is still required to verify the data. So machine learning model is the most powerful tool that many of you will ever use, but this power cuts both ways. So you need to use it wisely. You need to always verify what it tells you. Do not trust it blindly. You have to build with it. Don't deceive. And you need to have a human accountable to verify, to analyze the model that the machine is providing. So I hope we all remember the Spider-Man movie, the very first one, or maybe I am very old, in which Uncle Ben sends to Peter Parker, with great power comes great responsibility. And this is exactly what we need to take into account. Before we go, again, I would like to share some memories about our experience or my experience in Uganda. So I didn't come just to visit. I came to build, explore, and learn alongside Ugandans in the field and at the bench. That is exactly who AI needs. It needs people who understand the place and the needs. So the best time to start was years ago. The second best time is tonight. So do not hesitate to join our course provided by S-Tartex. Thank you for spending your evening with us. Webale, Uganda. Thank you. If you have any questions, please unmute yourself or drop them in the chat. Well, I guess there are no questions. Dio, I don't know if you want to point out something. Oh, sorry, we have one. Please, Simon Trevor. Sorry, I didn't see. Simon Trevor, you're. I cannot hear, but.
Yes, okay. So first of all, it's appreciate. Some of us are new to machine learning. And so this is a great way to start. My question is, if we are to quantify the time through which one can be able to attain a different status where you can, try to get some different levels of coding, like some you are showing us, how much time would you, in your own opinion, how much time would you give? Because this really, it provides a lot of skills, but it also takes work to learn how to use the different codes and how to apply them. If you could, thank you.
Yeah, thank you. Thank you, Simon. Yeah, that's an interesting question because believe it or not, once I graduated from my bachelor's, I also didn't know how to code. So the key here is to auto-educate yourself. So you need to learn on your own. And before there was no ChatGPT, Gemini, Google, and so on. So it was harder to learn. You needed to spend more hours. But now, as you can see from the live demo, when you start coding, the AI already knows and it helps you. It's a great help. So I would say still there are many courses available online. You can go to YouTube. You can go to I don't know if StartX will provide a coding course, but online there is also Coursera. But again, it's not free. I think it's like $40 for a course. So yeah, there are free tools. There are paid courses. So it's on everyone. But I believe if in case you don't have any experience with coding, so you want to go, slowly and try to push yourself. In the chat, I see one question from Macombe Richard. Do we require debugging of errors? Yes, of course. As you noticed, when I was coding, I was receiving errors, which is normal. So do not get frustrated if you code and you get errors. Many times when I was coding and there was no ChatGPT, it was very, very tough to find an error, and the error sometimes is very silly. So yes, you always need to debug to find where exactly your error is. If you have 1,000 lines of code and the computer gives you an error on your code, it's very hard to know where exactly the error is. So for that reason, it's good to debug line by line through your entire code. The other question is from Ajiko Samuel. I'm Samuel from Uganda. Would like to, after building models, what comes next, like saving them and use after saving. Could you elaborate more on your question? I couldn't get the question, please.
Yes, good evening, sir.
Yes, hi.
Yes, I'm Samuel from Uganda, as I said in the question in the chat. What exactly I would like to know is like how the first question is like how do you know if the model is bad or it's not the best fit? Then the other question is like after you building your models, after doing the model evaluation, what comes next? Like when you want to save your model and use it either to build apps or what comes next after building your models? Do you just leave them there or you have to use them to build apps and other things? How possible can it be done? Thank you.
Thank you so much for your question. Regarding the first one, no, not always your models are I would say most of the time wrong. And there are some ways to know whether your model is right or wrong. In the left demo, I didn't show it, but there in machine learning, there are two concepts. There is a concept of overfitting, underfitting, and you also need to see the error of your machine learning model, which I also didn't show because it's a bit more advanced. But based on the results you get, then you can improve if the results if based on on this parameter, if your model is overfitting or underfitting or your R square. The R square is a measure to know how far your machine learning model is predicting from your real data. If your R square is very low, then that means your predictions are wrong and you need to improve the model. And for the second question, how are we going to use the model after we build it? For the case of apps, to be honest, I do not know. I wouldn't know how to answer that question. But for example, in the case of machine learning, when you build, let's say, a neural network, you can build. I'll tell you my experience. During my PhD, I built a neural network model for solving a differential equation, and but in simple terms. After that, after I got the model, you can use that model. There is a concept called transfer learning. And the name, what it means is you transfer this model from very simple stuff to more complicated stuff. That stuff that is that requires very rigorous setups and so on. So yes, you can use the model you build to more complicated stuff. Yeah, and a question from Macombe Richard: is there a other specific programming language? Yeah, there are a lot of programming languages. One of them is Python, and as you can see, is very intuitive. The reason why I decided to show Python, it's because for beginners it's very simple. The way you speak is the way you write and is the way the machine understands. There are other programming languages like MATLAB or like C++, C Sharp, R. Those are more complicated models, and for those who are beginners in coding, I wouldn't recommend. I recommend starting with Python because it's the simplest one. And then if you want to explore other programming languages which are more complicated, then you can do that. A question from Anyanso Job Mark. How do I link my model to the system, like my website? Well, for that, for example, as you saw in Google Colab, when I was writing the code, the computer already know what I wanted, and it automatically showed me the let's say the code, and I just needed to press tab. This is possible because of something called agentic AI. So if you want to include AI in your website, in this case, you can do agentic AI, which will, let's say, read your mind. Whatever you are doing on the website, the computer will read your mind and out of nowhere will give you suggestions. But that is very advanced. That it's out of my expertise. Yes, I will share the notebooks and the recorder class with Deogracious, and he will be responsible of sending to you. Yes. I'm sorry. Can you write the question in the chat? I
Sir, can you write the question in the chat?
So, are there any other questions? Well, if not, or if you have future questions, you can contact me on LinkedIn. The Deogracious has my link profile. By the way, I can share it with you right now. Just a second. So in the chat, I wrote the link to my LinkedIn profile. So feel free to contact me to ask questions. So with this, I give the floor to Deogracious. I don't know if he has something to point out or to tell you guys. Dio, please.
Yes, thank you very much for very wonderful presentation, Jose. We really appreciate you for your time. And thank you everyone for joining. About the detail, Jose's detail, we are going to share everything in the platform. For those of you who are not in the platform, we are going to send a new email. Make sure that you signed in, you fill the form that we shared. And those of you who are requesting for the certificate, we are also going to share it on your email. So by tomorrow, you will be receiving your certificate already with your full names. Yes. Okay, so I think we are almost at the end of our webinar. Yeah, so I wanted to highlight two things. So I was already saying it, but the network was not good on my side. Yeah, so for people who are not comfortable with programming, so we teach them how to use tools like DeepMotion, DeepArt, ChatGPT, and also Gemini. So because I've been seeing some programming, so they were a little bit contemplating, you know, I've been receiving some messages here. So then for those of you who want to develop like a algorithm, so actually we take you through the fundamental of the Python and also develop them to where that they're able to use from the what to be used in the framework like TensorFlow and also deep learning. Those are the things I'm going to take you through. So after learning this, so some of you guys are also interested in the direction of robotics, so and hardware development. We will have to also take you through some of the you need to have some little knowledge in those two, on the machine learning and also artificial intelligence, and how you can use it to your software. I've had some question here, how can you integrate your model with your website? So I think Jose has given a very great answer there. So of course, we can also teach you how to use some of the tools like Flutter and also Reactive. So for those of you who are interested in building system like a embedded system, the IoT systems, and all those one falls under robotics. So we will take you through we'll introduce you to the hardware base, where that we will take you through some of the boards which we call Raspberry Pi and also Arduino, because I know some of you are familiar with Arduino, but when it comes to artificial intelligence, because it is a big model, so we need to start with the Raspberry Pi. So, but for the beginner levels, we can start Arduino as well, where we can develop some few projects in the IoT system and also embedded. So if you enroll in our course, which is mainly hands-on, we'll be carrying out various projects with artificial intelligence, where you learn a different project with a predictive algorithm and also models, how you can integrate it in your hardware. So we also teach all those things. Thank you for joining. For more information, we'll share them in our channel and also in your emails, since you already have the information. Thank you.